Hello everyone, hope you guys are doing well. We are solving today's LeetCode question, number of dice rolls with target sum. It's a median level question. We are given n dices, each dice can have k faces numbered from 1 to k. We are also given 3 integers n, k and target. We need to find the number of possible ways out of k to the n, total ways we will explain it further, to roll the dice so that the sum of face up numbers equal to the target. Now this answer can be very large, so we have to return modulo 10 to the power 9 plus 7. Let me explain what the question is trying to say. Let's suppose that I have in total n number of dices. For test purpose, let's just keep it as 2. And every dice has k number of faces. Let's say I just have an ordinary dice with 6 faces. Now what I need to do is I have to create some target. Let's say that I want to create the target sum of 12. At every dice, let's say a single dice can have in total k number of faces. In this case, we will have 6 in total. This will have 1 on top, this will have 2 on top, 3, 4, 5 or 6. And we can have any single face for a dice. Now, the sum of the total number of dice, let's say if I pick this dice, let's say when I throw the dice for the first time, I'm getting one on its face. So the total sum that is required for the second dice in order to create this target value will be 12 minus 1, because I have already created 1. I need to create 1 now. Now the thing about this is, because I only have 2 dices and I have to create a target sum of 12, no matter what the maximum value that I can get on this dice is 6. So I will never be able to create a target value of 12 if I ever get a 1 on the first throw. That's the basic gist of it. Let's see how we can solve this question. Let us assume, let's just try to draw it recursively what actually is happening. Let's suppose that the first time we throw our dice, we are getting, let's say, a 2 on the top. Let's also say that we have 2 dices that we can use, and let's say that I want to create, and they are ordinary dices, so like 6 faces dice, and I want to create a target value of 8. Okay, great. If the first face we are getting 2, for the second dice we have in total 6 ways. In the second dice we can get a 1, we can get a 2, we can get a 3, and so on and so on. In total we can get 6 over here, 6 ways. Now out of all of this ways, only this combination, when I'm getting 2 on the first time and 6 on the other dice, is when the total is becoming equal to 8, the target. So there's only one way in this configuration in which we can get a target value of 8. But the thing is, for the first throw itself, we can not only get 2, we can also get 1, 2, 3, 4, 5, 6 as well, for k is equal to 6. So for every k phase, we will again have k number of choices, and this goes on and goes on. So in total, the total number of ways from which I can choose will be equal to k to the power of n, because we will have n number of dices and all of these ways get multiplied. So we will have in total k to the power of n total choices. Out of this total choices, I need to see that how many combined sum is equating to target basically. Now, how can we solve this question? We will be using a DP, dynamic programming, or a recursive method. What we will do is basically we will generate all of the possible ways that I can get, all of the possible target, all of the possible combination of dice faces that I can get, and then out of all of those I will check which one of them satisfies my constraint. So that is basically what I will be trying to do. Let's suppose that I have 1 over here, and this can result, if I have, this can result in k more ways. On the first phase, we also had k ways that I could have chosen a phase. For every k ways, I have k more ways, and so on and so on. The thing is, why this can be solved using DP is basically, let's say that I want to create a target value of 8, and in the first try, and let's say that I also have a total number of 3 dices that I can use, and in the first try I'm getting, let's say, a 2. The question can be broken down into sub problems. Why? Because if I'm already getting a 2, I can reframe the question that I want to create a target value of 6 by using only 2 dices. whatever number of ways will be given by this, I can just simply add this to this answer and I will get the final answer. So we see that the problem can be broken down into sub problems. If let's say the second dice gives me a 1, I can say that I want to create a target value of 5 by using just one dice, and this again breaks down into a sub problem. So because we see that this problem can be broken down into sub problems, I can simply use a dynamic programming approach. Now let me show you how exactly the code is going to look like, and I will explain you alongside that as well. Number of rows, n, k, and target. Let's just create a helper function. Let's name it solve. Now this will contain the number of dices, total number of dices that we can use in total. I will have k. K basically signifies how many faces each of my dices have, and the target that I want to create. Now, what are the base conditions that we will be dealing with? If total number of dices becomes equal to 0, that means I have used all of my dices, and the target value that I want to create at this point is also 0. That means I have already created the target value. In that case only, I will return a value of 1, basically signifying that this is a valid way. Whatever combinations of dices, whatever combination of faces you have used prior to this, that is a valid combination. So I will return 1. If at any instance, if basically the total number of dices, not, let's say if the target becomes less than 0 or even equal to 0, and the total number of dices still hasn't become 0, that means that adding any more faces, adding anything to this value will reduce my target further. That means that this will not be a prior solution always, so I can just return 0 in this case. That is the second base condition. Now what else can be the thing? If anytime the total number of dices that I'm dealing with, this becomes less than 0 as well, in that case I also need to return 0. Basically I have utilized all of my dices and I still haven't gotten the target, so I will just return 0 in this case. I will just combine this with this thing, total number of dices. If ever it becomes 0 or even equal to 0, actually we will just return 0, because the first case handles when this is a valid combination, the second case handle if this is not a valid combination. Now what I will do is I will just create an integer called total number of, just create base, and I will initialize it to 0. What I will do is, for the current dice, I will go to all of the faces. That means for the current dice, for int I is equal to 1, it will start from 1 and I is less than equal to k. So what I will do is I will pick every face. Let's say I'm on dice number 1. I will pick all the faces. I will pick face number 1, pick face number 2, face number 3, and so on up till k. And I will, for the next iteration, I will say that do one thing. I have already used one dice, so reduce the value of dice by 1 and reduce the target value as well by the face that I'm choosing. I will just reduce the target value with whatever dice face I'm choosing, and then solve this question further. Basically I'm breaking down it to sub problems. So that is what this for loop is going to be for I less than and I equal to k. I will add this thing. What I will do, I will say that do one thing. Let's solve the question again using one less dice. The k will remain the same and the target will now be less by I, basically whatever face I'm choosing. Now there can be two things. I don't have to use this for loop till k. What will happen? Let's say that I have to create a target value of 3. Let's suppose I have to create a target value of 3 and the k is equal to 6. Basically I can have 6 total faces. Now if I'm iterating through this for loop, I will have a face number 1, I will have face number 2, I will have face number 3, I will also have face number 4, 5 and 6. Notice how whenever the current index becomes more than the target, this will never give me a valid answer, because if I ever pick 4, this is already greater than what I need to create. So this will always give me a wrong answer. Not wrong answer, but this will not be a valid combination. So what I will do in this for loop as well, I will see if this value of I is always less than equal to target, and then only I will do the following operation. I will not proceed for these. Basically I will not proceed for these values, because these values will always be greater than target if I was adding it to the total number of target, whatever the target is. This will always increase the value. This will always be greater than the target, so I will not process this. That's what I'm trying to say. So let's just do one thing. I less than equal to k, and I also need to check that I is always less than equal to target, or whatever target I'm trying to make. That needs to be the thing. So that is what I did. I less than equal to k, and then I less than equal to target. If that is the case, I just need to add it to the solution, and in the end I will just return the total number of ways that I can make it. This should give me an answer. If everything looks good to me, this should give me an answer. But let me just try to show you what will happen. If I do return solution of, initially we will have n number of dices, k will remain as it is, and target will remain as it is, because I do not have anything that has reduced my target yet. So I will just keep target as it is over here, and let's just call it for, let's say let's just call this function for ob dot let's say number rows to target. Let's take one from the test condition as well, 1, 6 and 3. 1, 6 and 3. For 1, 6 and 3 there is only one way to make 3, and that is if the dice, because I only have a single dice, the only face, if my dice is having 3 on its face, then only I can make that. Otherwise there is no way I can make a target value of 3. So this should result me with an answer of 3. Sorry, 1. There is only one way of solving this. Okay, fine, that looks good to me. What is the next way? 2, 6 and 7. 2, 6 and 7. This should result in 6 total number of ways, which is right. Okay, so basically the function looks to be working, but if I give it a big enough input, let's say I have 30 number of dices, and each number of dices has, let's say 5, each number of dices has 30 faces as well, and I want to create a target value of 500. In that case, this will not give me an answer in the time. I will basically have a time limit exceeded. Why is that? The reason for that is that this is a factorial time. Basically the time complexity currently is factorial. It's k to the power n. I'm generating k to the power of n all possible ways. So this is not going to give me a valid answer, and second of all, the answer can be very large, so I have to return modulus 10 to the power 9 plus 7. We will look how we can do this. Basically, let's just try to optimize this first. How can we optimize this? Basically, whenever we are dealing with a DP problem, we can solve it by, we can basically optimize it in two ways. I can either proceed with tabulation, or I can either proceed with memoization. Memoization is always the simpler way, so I will just proceed with memoization for this case. How I can memorize this function is, let's say I create a vector of vector. I just create a two-dimensional DP. Why two-dimensional DP? Because there is two states, two parameters, this total number of dices which will be changing, as well as the target which will be changing. So I will have to create that many dimensions as many parameters are changing. So in my case, 2 parameters are changing, so I will create a two-dimensional DP array. I will create a two-dimensional DP array. Let's mention the dimensions as well. The total number of dices, the maximum total number of dices can be n. So for I will just accommodate for overflow, and I will just say n plus 1. N plus 1 total number of rows, and for the second value, which is every vector as well, we will have the value of target can goes to target itself. So I will just say target plus 1, and I will initialize all of them to -1. So this is, I have initialized a DP. Now what I need to do is I will pass this DP to this function, and I will take this as a parameter over here. I will just say vector of vector int, and I will just pass it by reference. Now what we need to do is we need to check here if I have already calculated the answer. If DP for total number of dices and target is already calculated, that means it is not equal to -1. That means we have already calculated the value. I will not calculate it further, and I will just return whatever I have calculated prior to this. Or just return the answer. I don't have to calculate that again. First thing. Now second thing, whenever I'm just returning ways, I will also store it in our DP, so that number of dice, so that I don't have to calculate it if the same condition occurs in future. Target, there we go. So this should give me the answer as well. This will be optimized as well. If I just pass everything, yeah, that looks good. Let's run this thing and see, I am getting an answer. But the thing is that my answer will be getting overflowed because this will be a large number. So that's why I'm getting a negative value, because my answer is getting overflowed. What I can do, as the question is stated as well, I need to return it modulus 10 to the 9 plus 7. How I can do that? I can simply just do, let me just define mod first. Const int mod is equal to 10 to the power 9 plus 7. This is what I'm supposed to take modulus of. Whenever I'm adding this value to here, when I'm calculating the value, let's just say that I also take the modulus here as well. Mod. There we go. That looks good. Let's run this again, and this is the value that I was expecting, and this is also the value. So let's just try to submit this. Let's just try to submit this solution and see if this passes or not. Control V. It's submit. Let's see if everything goes right, and it did get right. Okay, I'm getting a runtime of 23 milliseconds. That looks good, 70%. And so that will be it. If you have any doubt about the approach, if you was not able to understand what I did at any step, you can just let me know in the comment. Otherwise, thank you guys for watching. Bye bye.